our today's discussion. We're going to discuss about the normal approximation to binomial distribution. So, when do we use the normal approximation in approximating binomial distribution? Number one, the normal approximation can be used when NP is greater than 5 and NQ is greater than 5. So here we find that when X, for example, is assumed to be the binomial distribution with N and P. When NP is greater than 5 and NQ is greater than 5, X will be now assumed to be normally distributed with mean NP and variance NPQ. Example 1, we find that it is given that 40% of the population supports education. 150 members of the population are selected at random. Use a suitable approximation to find the probability that more than 55 out of the 150 selected supports education. Now here we realize that our P is 40%, which is 0.4. Therefore, our Q is 1 minus P, which is 1 minus 0.4, which is equal to 0.6. So our P is equal to 0.6. And 150, which means N is 150. Using a suitable approximation to find the probability that more than 55. So we want to find the probability that X is greater than 55. Now here X is assumed to be binomially distributed with N and P. Now let's look if we can use the normal approximation or the Poisson approximation. To test this, NP should be greater than 5 to use normal approximation, and NQ should also be greater than 5. Our N is 150, so we have 150 times P. Our P is 0.4. This is our Q. Our P times 0.4. It should be greater than 5. We find that 150, when you multiply 0.4, is 60. And 60 is greater than 5. Let's confirm this. N is 150. Our Q is 0.6. It should be greater than 5. When you multiply 150 by 0.6, we find it's 90. So we can, using a suitable approximation, we therefore use the normal approximation to approximate the binomial distribution, since we've confirmed that NP is greater than 5 because it's 60, NQ is also greater than 5. Now our X now will be assumed to be normally distributed with NP, NPQ. So our NP is the mean, NPQ is our variance. So our NP is NP, we realize that NP is 150 times 0.4, which is 60, and NPQ is N is 150 times P is 0.4 times Q 0.6. When we multiply that, we'll have 36. So our X is now assumed to be normally distributed with the mean 60 and the variance 36. Now our question was to find the probability that X is greater than 55. Since we are using a continuous, normal distribution is continuous distribution, while binomial distribution is a discrete. We therefore use the continuity correction. Since when the probability that x is greater than 55, we will therefore add 0.5 to 55. Therefore, using continuity correction, we have the probability that x is no greater than 55 plus 0.5. So we have probability that x is greater than 55.5. We now standardize. Standardizing, therefore, we'll have probability that x is greater than 55.5 minus 55.5 minus our mean, which is 60, divided by standard deviation, which is the square root of 36, which is 6. When we solve this should be z, since we have already standardized. When we solve this, we'll find probability that z is greater than negative 0.75. We realize that normal distribution is always normally distributed. Therefore, this can be written as probability that z is less than 0.75. This is due to the property of symmetrical. The area of probability of z greater than negative 0.75 is the same as probability that z is less than 0.75. And this is gotten by phi of 0.75. Now, phi of 0.75, we look at our table, the z table, we will find it's 0.7737. Phi of 0.75 is equal to 0.7737. Therefore, our probability that x is greater than 55 is equal to 0.7737. We realize that the probability that more than 55 out of 150 support the education is 0.7737.